Welcome everyone, and I hope that everyone can hear. I'm a wee bit blinded by the light, and I think this is the experience you'll have in a few minutes, Sheila. But welcome to Aberdeen University for those of you who are visitors. It's my very great pleasure to introduce Sheila Cunningham, our Professor Sheila Cunningham, who's giving her inaugural professorial lecture tonight. Sheila's been here at Aberdeen for 14 years now, and actually I've been very privileged to work alongside Sheila because she's had a whole range of roles when she's been here, and does espouse very many of the qualities that we'd like our professors to show, because it's not just her own development that she's kind of enabled along the way, but she's also supported many, many colleagues and also many students as well. So I'm really pleased to see that we've got students in the audience. I'm not quite sure who's all online now, but if we've got students there as well, welcome. And also welcome to our colleagues that are online. Sheila, as I say, has done many roles for us along the way, not just her research role, but obviously is active in the classroom, but also has taken on programme leadership roles too, and continues to do that. So she, as I say, she does really, do the breadth of the academic sort of work that we want our colleagues to engage in. And I say she has supported, certainly mentored very many colleagues along the way, and these are exactly the things that we would like our professors to do. Sheila's research is very much in the childhood development area, which you're about to hear about. I know she's done work around about gender stereotyping. She's done work about the identity and development of self as the child grows, and also particularly in relation to things around about how that self identity develops in children who've maybe got additional learning needs, and I know has had some research funding to support that particular activity. So I'm going to hand over to Sheila, who will do a much more eloquent job of telling you about her research. So Sheila, over to you.
Thank you. I think I can just go off. Thank you. Thank you so much. It's really nice to have a captive audience of my family and friends. Sorry. Yeah, so thank you. The purpose of today's talk is kind of to give you an overview of 25 years of my research in this area, why I think it's important, hopefully interesting. I can't actually see your faces in the darkness here, so I can't tell if you're not finding it interesting, so I'm just going to hope. What we're going to focus on is social cognition biases, and particularly those relating to the self, and what they are, how they develop across childhood, as Andrea mentioned, but also how we can harness them to make them useful for society. So, sorry. I'm not going to spend too much time doing any sort of personal journey because I'm too self-conscious for that. But for context, I am going to go through a bit about the research pathway that I took, just because it gives you a bit of context about what we're going to talk about today. So I started off doing my undergrad degree at Aberdeen University, which is obviously a very beautiful university, but as anyone who studies psychology will know, you're always in the ugliest building, so this is where I spent my time. I always really enjoyed the social psychology classes. That was my favourite aspect of my undergrad degree, partly because it's about understanding people, and people are obviously very interesting, but also because studying something as complicated and variable as social psychology involves designing really interesting experiments, and that always fascinated me. So when I finished my degree, I worked with the late great Alan Milne on stereotyping research. So I focused on things like how stereotype use is affected by executive functioning limitations, and about how that links with prejudice and how that might vary in different contexts and with different conditions. So as part of that, we looked at things like memory and attention and the way that stereotypes bias social information processing. But actually today I'm not going to focus on stereotypes, although it is a big part of my work again, because after that research I took a sort of slight different turn away from looking at the way that we process information about other people to how we process information about ourselves. So I worked with Neil McRae and Dave Turk at Aberdeen on a couple of postdocs, and as you can see from the ideas on screen just now, a lot of the concepts that we associate with self-processing from a social cognition perspective actually overlap quite a lot with stereotypes. So again, things like bias processing, memory, attention, all these different aspects of cognition that affect how we process types of information. So really there's actually quite a lot of overlap. You can think of the self-concept in some ways as functioning a bit like a stereotype in practice. So for the focus of today, we're going to focus on this self aspect of processing. So the first task is generally to introduce what the concept of the self means. That's easier said than done. In terms of both philosophers and psychologists, we tend to divide the self-concept into these two different aspects. So one is the subjective experience of selfhood. So this is the idea that we exist as a continuous being across time. The kind of conscious experience of being a self, you know who you are today is the same person as who you are 10 years ago, 20 years ago. These things are really difficult to capture experimentally because it's such an experiential aspect of the self. So psychologists tend to ignore it because it's difficult to study. So instead, what we've tended to focus on, or certainly what I've tended to focus on in my career, is what we would call the objective self. So rather than the experiential aspect, this is more about what we know about ourselves. So that might include things like what you know about your personality, what you know about your experiences, so your autobiographical memory system, how you feel about what you know about yourself, so your self-esteem. These things are measurable. So experimentally, we can break them down, look at the mechanisms, and find out what's going on at a cognitive level. So as part of that focus on the objective self, a big part of my research has been on the self and memory. And these are really very intertwined concepts. So if you think about the experience of being a self across time, then you need to have autobiographical memory to support the continuity of that experience across time. So without autobiographical memory, it's very difficult to have a sense of identity. And we know that from neuropsychological studies with patients who have damaged their autobiographical memory system. And another function of the self is to provide an organising structure, so to provide a network into which we can integrate knowledge into an autobiographical memory store. So this kind of integration of information is a real byproduct of having a concept of self. And that in itself actually produces biases that are quite interesting to study. So before going on to my own research, I just want to give you a wee bit of background by sharing the most well-established of these effects, which was first described nearly 50 years ago, which is the trait recall paradigm. And this was the paradigm that first launched the idea of having what we call a self-reference effect in memory, which is just an advantage for information that's been processed with reference to self. So in a self-reference effect paradigm like this, you have participants asked a series of different questions about a number of different character traits. So they'll be asked questions that involve themselves. So are you creative? Are you tidy? Are you modest? And then they'll be asked questions about maybe another referent person. So someone that's well known, but maybe not close to them. So like a celebrity. Is Taylor Swift calm? Is Taylor Swift tidy? Or they might be asked about semantic characteristics of the word. So is modest a positive word? If you then test their memory for the character traits, then the ones that they encoded with reference to themselves are reliably better remembered, regardless of what type of memory test you use, and across a whole different series of comparison conditions. So this is the self-reference effect in memory, a memory advantage for self-related information. We've known quite a lot about the mechanisms that support the self-reference effect at some level for quite a long time. So we know that we have a really rich autobiographical memory store. We know a lot of information about ourselves. So we have all our experiences that are associated with ourselves in memory. We have all the semantic information that we associate with ourselves, so our knowledge of things that are about us. And that's a kind of organised, rich, accessible framework in memory. So if you're encoding new information and you can slot it into that existing memory, then that's much easier in terms of both encoding and retrieval. So you get rich representations because they're being enriched by the information that's already stored in memory. They're also more organised, so when you're trying to retrieve the information, if you activate one part of that structure, you activate all of it. So that means that there are multiple routes to retrieval. So when you're encoding things with reference to self, you're able to make use of all these mechanisms that provide really good memories. Our own research in this area started with the question about what happens if you're trying to encode, if you're trying to look at self-referenced memories that are not associated with the task of consciously thinking about yourself. So in all the research that had been done before, people are asked, how does this characteristic describe you, for example. You're consciously retrieving autobiographical memories, and that then provides this support structure. But if you're just going through your everyday life, you're not going to be thinking about consciously, how does this apple relate to me, or how does this experience make me think about myself? We don't really interact with the world in that way. So what we wanted to do was to find a way of testing more minimal associations, more everyday associations that people have with self. And so we started looking at something that has become known as the ownership effect. So we developed a paradigm where people were given a series of objects, and they were asked to sort them into two baskets, and they were told, say you are the red participant, everything that goes into the red basket belongs to you, or you're the blue participant, everything that goes into the blue basket belongs to you. And then we just show them a whole series of items with an ownership cue. So if it's got a red dot, it goes in the red basket. If it's got a blue dot, it goes in the blue basket. And they might go through 50, 70, 100 of these objects, and then we test their memory. And when we do this, we get a really reliable ownership effect. So what this graph shows here is that the information that was encoded with reference to self, so the self-owned items in the red, are associated with better memory than the items associated with the other person. This is quite a small memory advantage, but what's quite interesting about it is that it happens in almost every participant. So we see this small but consistent, robust advantage for the items that were encoded as owned by self. Now the participants know they're not going to go home with these items. So it's not like they're having to take this task particularly seriously or to consciously activate self-information, but still they remember more of the ones that go into their own basket. And it's such a robust effect that we've tested in all sorts of different ways. We know it works in adults, we know it works in children, we know it works in different types of memory, whether we're testing recognition or recollection. We know that it works with if people are choosing the items or if they're just assigned the items, like the example I showed you, it just works. So it's a really powerful effect. And it's interesting to think about why it works. So there might be some level of self-knowledge activation. So if you see a picture of an apple, you might activate memories of times where you have bitten into an apple or enjoyed an apple, or you might think about semantic information about yourself, like, I know I like apples or I don't. Or you might think that you have to buy apples on the way home. It's possible that these self-knowledge representations are being activated at encoding, but it seems a little bit unlikely. We also, from interacting with participants, can see that they just care more about the things that are associated with themselves. So if they get something to own that they like, they're really pleased. If they get a bottle of vodka, they're cheering even though they know they're not going home with a bottle of vodka. So things that are relevant to them, things that are going in their basket, even if it's just within the confines of that task, attract attention and seem to be prioritised in cognition. Because we couldn't really tease these explanations apart in this particular experiment, what we did was to try and design a study that could test a really minimal level of self-association to see how that impacted on people's memories and processing. So this is work that was led by Dave Turk. What we did was we presented participants with pictures of themselves. So I'm sorry to have my face massive on screen here. And then a character trait is presented above or below the face. And then other trials are presented with a picture of a celebrity, and character trait is presented above or below the face. And the standard version of the task is what we call an evaluative self-referencing task, where they're just having to evaluate whether the information applies to them or the other person. So that's a standard trait recall task. So does the word describe the person, yes or no? Another group of participants were in a different condition, which we called incidental encoding. I slightly regret these terms because I get that they're not very easy to bear in mind, but incidental, we called it this because the face is completely incidental to the task. All participants are asked to do is to say whether the word is presented above or below the face. So it doesn't matter who the person is. They're exposed to the face, but they're not having to process it. They just have to say yes or no, is the word above or below the face. So in these two conditions, they're presented with the same stimuli for the same length of time. They're giving the same responses. The only difference is whether they're having to activate self-knowledge at encoding or not. So when we look at their memory for these trait words, this graph on the left-hand side here is the evaluative condition. So again, as you can see, the information that was encoded with reference to self in the orange is significantly higher than the information that was encoded with others, so they remember more of the trait words they encoded about themselves. It's not particularly interesting, it's just the classic self-reference effect. What we were really interested in is what happens in the incidental condition. So the face is on screen, but they're not having to process it. So here we get overall lower memory, because they're doing a sort of shallower level of processing, but the self-reference effect is still significant. So they're still remembering more information when their own face is on screen than when the other person's face is on screen. And in this condition, there's not really the necessity to even process who the person is, let alone activate any stored self-knowledge. So if it's not about stored self-knowledge, what is driving this effect? Well, there's lots of evidence that self is treated across cognition as a priority stimulus. So this prioritization hadn't previously been linked with memory specifically, but we've known for a long time that if you have a cue that's associated with yourself, then you're likely to pay attention to that cue. So if you hear your name across the room, or if you were scrolling through social media and you saw a picture of yourself, there's no way you're not stopping and checking out what the context of that picture is in. So if there's a cue that's related to you, that will be prioritized in attention, and your attention will be drawn to that stimulus. So the whole system is designed to make sure that information that is about you is not missed and it's not forgotten. And this is a kind of functional adaptation. So it makes sense that we've evolved a system that prioritizes paying attention to stuff that's relevant to us. So if you were in the ancient ancestral environment and you had some meat or some relatives or some weapons, it's important that you keep track of what information is yours and what information relates to you. That's a functional adaptation. So our response to the self cues seems to follow the pattern of other stimuli that we associate with that sort of functional adaptation. So like threat stimuli. So if we see things like pictures of snakes, sorry to my dad who's a bit scared of snakes, I probably shouldn't present this in front of him, or angry faces, that will attract attention away from other things that are on screen because we are programmed to detect threatening images. We, in fact, recently published some work showing that self-cues attract even more attention than these sorts of threatening images, so it seems like self is really a priority in the cognitive system. So this is kind of interesting theoretically, but it's also potentially quite useful. There's a few different ways that we're trying to make use of this pattern. We've done some work recently with Neil Kirk looking at your own voice cues. So recording snippets of people's own voices and using them in experimental programs to see where attention is drawn. And what we find is that your own voice is prioritized, as you would expect, but so are other voices that are encoded in the context of the experiment as associated with self. So think of them almost as being owned by self in the context of the experiment. And that could be useful for different applications, like people who use artificial voices. There's been some work about the connection with these voices, so we can study using this sort of paradigm the extent to which different characteristics, like how similar the voice is to self, or whether it matches on key personal characteristics like gender or accent, how much that matters in terms of the attentional capture, in terms of the extent to which that voice replicates the patterns that we associate with self-processing. It's also useful for things like use of avatars in gaming. So that's quite an interesting line of work. A second quite interesting outcome, for me both theoretical and practical, is looking at working memory. So working memory is the system that we use to keep information active while we're processing it. So while we're thinking, we've got this information active, we can operate on it, make changes to it and reproduce it. This is work done with Zara Ahmed and Janet McLean and Kevin Allen. In fact, Zara's PhD work on this was our links funded. I just want to talk you through an example of an experiment that she developed to show this. It's a little bit complicated to explain, so stop me if it's not making sense. But what happens in this task is that you have what we call a complex listening task. So participants are given a sentence and they have to process the words in the sentence. They have to answer a question. And then their memory is tested by getting them to repeat the last word of the question. So if you just look at the column on the left here, this has got my name in it. So this is a self-referent set of questions. So Sheila likes to eat ice cream. The participant has to respond yes or no, depending on whether the question makes sense or not. So if it makes sense, like this one does, as a participant, I would have to say yes. Sheila eats with a knife and plane, I would say no. And then my response, my test, would be to say ice cream and plane. And so we have examples of these sorts of sentences that are referent to other people or that have no reference in them at all, control conditions. And what we do, or in this example here, what you see is a span set of 2 sentences. So if participants were able to respond with the 2 words correctly, they would be given a span of 2. And then participants would then try a set of 3, and then a set of 4, and a set of 5 to see what they can get up to. And the largest set that they can remember accurately all the words from is their span score. Does that make sense? Okay. So what I'm showing you here is a span score, which is a multiplication of their span by the number of attempts that they take. This pattern here is from adult data in Zara's thesis, but actually it's surprisingly consistent in children. And this is the pattern that we see. So the words that start with the participant's own name produce a higher span than the words the sentences that don't include the participant's own name. And that's kind of remarkable. It might look simple there, but actually being able to increase working memory capacity just by including one word is kind of phenomenal to us. So we have some kind of speculative explanations for it. One is that your attention is captured automatically if it's a self-cue, so it might be that that puts less pressure on the attentional system to have to decide where attention is being focused within a task. Might also be a contribution from the fact that familiar concepts, so things that are associated with self, would be familiar. It might be easier to maintain, so it might be easier to retrieve the information from long-term memory. But given that half of the sentences were nonsensical, I don't think that's a strong contributor. What we think is happening is to do with binding. So binding is this really interesting idea that when you have information that you've got, that you're encoding, taking in from the external world, we bind it into chunks. So we sort of remember it in groups. So if you're thinking about a phone number, for example, you don't tend to remember all, say, 9 numbers separately. You try to remember them in bunches of 3, or you chunk them together. And when information is bound together in these chunks, then it requires fewer working memory resources because you're not trying to remember as many disparate items. So we're starting to see some evidence that self-cues increase binding, and that will increase our working memory capacity. So we'll come back to this idea later, but just to sort of recap the first part of the talk, the self-processing biases that we know are kind of driving some of these memory and attention effects. We've got a self-cue, if it's presented, is likely to lead to attentional prioritization. So whatever is in the environment at that time, your whole system is telling you, this is important, attend to it, don't miss it. Whether it's your own name, your own face, your own coffee cup, whatever it is, if it's to do with you, it's important. And then we have all our stored self-knowledge. So the autobiographical memory that we have, if we're activating things in the context of the task, if the task is activating the self-knowledge, then that provides that extra support to the memory. So we've got both these sort of low-level attentional processes and these more conscious memory processes going on, that both of which have the capacity to prioritize information. So that's kind of the mechanisms. what a lot of our research has focused on in the subsequent years was looking at how we would expect these mechanisms to develop in childhood. So we know from different experiments that children do show some of the attentional prioritization effects at quite a young age. So children show ownership effects from about 3 or 4 years. They show attentional biases in middle childhood. But what they don't have at a young age is a very large autobiographical memory store. So they don't have a huge amount of self-knowledge that they can then apply if they want to support their memory in that way. So because of that, we could make some predictions about how these effects are likely to emerge in childhood. In particular, attentional prioritization we know is there in young children. So we might expect tasks that are driven by these kind of low-level processes to show strong self-effects in young children, whereas if we're looking at memory supported by self-knowledge, then we might expect that to develop later on, once children have got more ability to use this knowledge effectively to support incoming memories. We know that self-knowledge becomes more complex in middle childhood, and also children develop a better ability to integrate information with existing information, and that also increases at that middle childhood stage. So we had some predictions about how these effects might emerge across childhood. So we, as part of an ERC-funded project with Dave Turk, we developed some new methods of testing these with younger children. So we tested hundreds of children on these evaluative and incidental encoding tasks. Because children can't process, or young children can't process the character traits that have been used in adult self-reference effects, what we did was we made concrete versions of these tasks. So just to show you an example, you have, sorry, this is my children's faces, they're not looking happy. A child would see their own face come up in the middle of the screen, and then a concrete object come up on the left or the right of the screen, and then in the evaluative encoding condition, what they're asked is, would this person really like this object, or would they not be that fussed about it? And they just have to press a button. So they're not having to process character traits, but they're having to activate self-knowledge. They're thinking about themselves consciously in relation to this item. In an incidental version of the task, you have the same or a different child with an object coming up on the left or the right, and this time the child's task is just to say which side of the screen did the object come up. So they test the button on the left or the right. So they don't have to process the face. The face is incidental to the task. So when we look at their memory for the objects that were presented, if you remember from the adults, we had this pattern that you got a self-reference effect in both types of encoding, but in the evaluative condition it was much bigger than in the incidental condition. So when we look at young children, so this is 4 to 6 year olds, we show a self-reference effect in both conditions, but we don't get the same boost in the evaluative condition. So the size of the self-reference effect is the same in both conditions. So this is quite exciting because it follows the predicted pattern. We expect the incidental condition to be driven by this kind of attentional prioritization. My face is on screen, so I need to attend to this. This must be important. Whereas the evaluative conditioning, where they're adding the self-knowledge, that's not really giving them that extra memorial boost that we see in adults. So that was a first demonstration that this kind of this pattern might emerge later in childhood, but we needed more evidence and more over a longer developmental period. So we were lucky to get funding from the Leverhulme. I think Josephine and Jackie are here tonight, and they will hate to see their photo on screen. But we again tested hundreds and hundreds of children on a number of developmental tasks, so looking at their self-knowledge, their understanding of self, their autobiographical memory, and their self-referencing. And what we see was some qualitative changes in children's ability to store information relating to themselves. And this kicks in at about 8 or 9 years. I'm not going to go into the tasks in any detail here, but the important point is that what changes at about 8 or 9 years is children get a much more abstract understanding of self, and they get a shift in this ability to integrate knowledge into the self-knowledge framework. And when we model it statistically, what you see is that the links between that there are statistically significant links between self-knowledge and how much of a self-reference effect the children showed, even when you control for age. So it suggests that whatever's happening at this time, the self-referent processing and self-knowledge and self-memory are all developing in tandem. And when we compare the evaluative and the incidental encoding, so remember, young children, we see a similar self-reference effect in both types of encoding. Adults, we see a bigger self-reference effect in the evaluative condition. This is the data from the 8 to 9 year olds. This is the first stage where we start to see that adult pattern developing. So it's really nice because it's just at the time that we were hoping it would come. And we replicated our previous finding that in younger children, you don't get this pattern. So as predicted, at 8 to 9 years, you get a larger self-reference effect in the evaluative condition than the incidental. And then you gradually see that evaluative effect get larger across childhood until about 10 to 11 years, you see the same sort of magnitude that we see in adults. So that's quite a nice kind of logical set of data that supports the developmental pattern that we predicted. So developing kind of early attentional prioritization, and then gradually as children's memory systems develop and their self-knowledge framework develops, you get this additional boost from memory support. So in case you're all starting to nod off, I can say this is interesting to me because I like this sort of nitty-gritty. But why should you care about this? Why might it be interesting to other people? Well, I think this matters because we should be applying it to the real world. So if we know that self-cues impact attention and memory, then surely what we should be doing is applying these to learning, both at schools and at universities. So in the last part of the talk, all I want to do is to share some studies that we've done looking at different ways that we can explore this. So one of the first things we did was to look at ownership tasks, because really that's one of the simplest things that we could think of that would translate easily into a task that people would do in a school environment. So we used flashcards and we asked children to sort out some cards that each had a novel shape on them. And the shapes all had a novel 3-letter name. So the children are sorting out a bunch of cards into 3 different baskets. One basket belongs to them, one belongs to me as the experimenter, and one is unowned. So in this example, the child might have the blue basket, so any card that's got a blue dot goes into their basket. Any card that's got a red dot goes into my basket. Any card that's got a green dot is not owned by anyone. So they're just sorting out these these cards, and then the cards are put away, and at test, what we ask them to do is to draw anything they remember. So any shapes they remember, any of the words they remember, just a free recall task. So we had these scored by other people, so they were blind, and then this is the sort of data that we got. This is the recall scores. So you can see there's actually quite a big effect here. The self-referenced shapes, so the shapes that went into the child's own basket, were better remembered than the ones that went into my basket or the ones that were unowned. This is a really simple task, and the children are not spending any more time looking at their own cards relative to mine or the ones that are unowned. We've done it in different ways where the children choose the items. That makes no difference, you get the same pattern. And we've also contrasted it with a control task where the children sort the items into the 3 baskets while nobody owns any of the baskets, because that allows us to make sure that any advantage for the self-owned shapes isn't coming at the expense of losing information about other shapes. And when you explore this statistically, the unknown shapes are not significantly under control and the other 2 are significantly above control. So it's quite a nice simple task that if teachers are trying to get children engaged in things that they might not inherently find interesting, they can do something that's fairly adaptable. And children are often having to learn fairly boring information. There's no getting around the fact that sometimes children just have to learn stuff. They have to learn second language vocabulary, they have to learn scientific information, they have to learn facts, they have to learn spelling, they have to learn stories of 10. Giving teachers something practical that they can use in the classroom is quite an attractive idea, given that it's based on solid evidence. But of course, that's not the sort of task that you can apply to every learning situation. For literacy and numeracy tasks, we've investigated different ways of trying to activate self-processing during the task. One thing that we did early on, this is with Carrie Gillespie-Smith and Dave Turk, is that we investigated what would happen if we took over children's homework and made them use personal pronouns while they were doing their homework task. So we worked with a couple of schools who were doing this traditional homework spelling task, where the children have, say, 10 words to learn each week and they have to write them out 3 times and then write a sentence about each one. Children tend to find this quite boring, but a lot of schools still use it every week. We developed a couple of tasks to use. In the first experiment, we just did a classroom task where we gave them some non-words. These were the names of characters, and we asked them to write a sentence about each of the characters and what they would do if they had to spend a day with them. And the names of the characters were the spelling words. So they wrote them out 3 times, and then they had to write a sentence about each one. Children in a different condition had to write a sentence about a different cartoon character spending a day with each of these aliens they were. In the second experiment, we took over children's actual homework. So we did a baseline week, and then we had 2 subsequent weeks in a random order depending on the child. One week they had to start each of their sentences with the word I, and in the other week they had to start each of their sentences with the word Harry for Harry Potter. So they were writing about themselves or they were writing about Harry Potter. And actually we were setting ourselves up to fail a bit, because this was a few years ago and people were obsessed with Harry Potter. But yeah, the children were thinking about themselves in one condition and not in another. And what we found was that in both of the experiments, in the self-referent condition, so when they were writing the sentences about themselves, they're not writing the word that they're trying to learn any more times in that condition, but we had significantly better spelling performance in their end of week test. In the first experiment, the increase where they were using non-words, so they didn't have a sort of baseline, the increase was 30%. In the second experiment, it was about 13%. They also wrote significantly longer sentences when they were writing about themselves. And when we talk to teachers, this is something that we find that some of them do automatically. So teachers will say that, say if they've got a child who's struggling to start a story or is struggling with a sort of generating some information, if they encourage them to think about themselves, they quite often get results. They might do that spontaneously. But we now know why that works. So they've got autobiographical memory support and they've got attentional engagement because they're using self-cues. So that was quite cool. We then got some funding to do a deeper dive into the effects of personal pronouns on different literacy and numeracy tasks. This was a UKRI funded project, an entirely school-based 3-year project that started in spring of 2020. Can you imagine? But this amazing team got everything done, so we managed to get through it despite the challenges of testing. One of the tasks that we used was first reported by Dai et al. More than 20 years ago, but actually no one had ever followed up. But it really fitted with the predictions we were making, so we wanted to test it properly. Take this example of a normal classroom word problem-solving task, the sort of thing that children are exposed to all the time. So Jake has 3 apples, Chris has 2 apples more than Jake. How many apples does Chris have? So the children have to parse the information, they have to read it, they have to keep it active in working memory, they have to work out what the operation is that they have to perform, then they have to remember what the numbers are and who they were associated with them in order to produce an answer. So there's quite a high working memory load, as well as just the mathematical processing. So we tested what happens if you change the referent. Swap one of the referents out for the word you. So you have 3 apples, Chris has 2 apples more than you. How many apples does Chris have? And what we found was a replication of Dai et al.'s finding, a small but really robust difference in both accuracy and response time. So on the left we've got accuracy, and even though the children were pretty good at this task, they're fairly close to ceiling, we still got a strong, robust effect, whereby they were more accurate if the problem had a personal pronoun. And then on the right-hand side here, you've got response time. So not only are they more accurate, but they're faster. So this problem is easier for them. They find this easier to process. They're better at it and they're faster. So bringing this back to the theoretical explanations, we know that if we've got a word like you that's self-referent, we're going to bring up that advantage and attention and working memory processes. But we also think that binding might be really important here. So we talked about this idea earlier of self-cues binding active information into chunks so that they can be held more easily in working memory. So if you think about this sort of problem, you have 3 apples can be a chunk. And if you remember you have 3 apples as a chunk, when you're trying to remember once you've worked out what the operation is you have to do, and you have to go back and check, well, who had 3 apples or who had 5 apples, if that information is stored as a chunk, you might not have to revisit it as much. If you've got fewer units of information to keep active separately if they're self-related. And we were able to test this using eye tracking technology. So an eye tracker is just a bar that sits on a laptop that monitors where people's eyes are focused on a screen. So we took this into schools and we gave them the maths problem solving exercises, and we watched where they looked on the screen. So what you do is you present a word, you have to space out a little bit because our eye tracker is not world beating, and you can divide that screen into different boxes, and you can then use the eye tracker to calculate the total fixation time on each box. So here we have things like reference, numbers, nouns, joining words, operation words, and we can then look at what fixation time differences between the self-referent condition with you and the other referent condition. We used a short familiar name like Sam. What differences between these conditions are being underpinned by particular areas of the screen. So when you look at fixation time on all these different types of boxes, there's only one that ends up being significantly different reliably between the conditions, and that is the referent term. So in all of the others, you get a similar amount of fixation time whether the first word is you or whether the first word is Sam. But looking at that particular box that represents the referent term, whether it's the first word or later on, we have less fixation time in the self-referent condition. So it supports the idea that the children are not having to go back and revisit difficult things. We know when there are harder sums, so when there are bigger numbers involved, for example, they do have to do a lot more revisiting. So it seems to be a kind of proxy measurement of how simple something is to solve in terms of numerical processing. So the self-referent condition is easier. They're having to revisit this information less. They're able to keep it active in working memory while they solve the problem. And that seems to be associated with producing that advantage both in accuracy and in speed. So we know what happens in terms of self-processing biases. We know about attentional prioritization. We know about the support from memory. We also know that it happens early, and then the memory support develops across time, and we know that it matters. So we know that we can take these theoretical ideas and an understanding of the mechanisms that support these different processes and apply them in practice so that they can have a meaningful and useful effect in society. So I'm going to wrap up, but what I wanted to get across, or what I hope I've done, is shown a bit of the potential for psychology, not just to be interesting, but to be applied. So I think it really captures the kind of dual purposes of a university, really, to promote research, theoretical research, blue sky thinking, but also to understand applications to society and how research can be used in the real world and directly in teaching. And while today I've focused on self-processing, I would have loved to have time to talk about other things, but I don't. So what I have shared here is a link to the Gender Stereotypes Lab, where we're also looking at the effects of social processing biases on things like gender stereotypes and educational decision making, with Lara Wood and Jackie Hutchison and Karen Golden. So if you're interested in that, I would encourage you to check out our lab website. But yeah, lots of interesting ways in which we can take this theoretical knowledge and apply it to society, particularly for me in education. And that's all I really wanted to share. So for my non-psychology friends who have put up with this, I appreciate you being here and being a captive audience. It feels quite indulgent. To my family as well, who are here to support me today, thank you very much for all your attention, and to everyone who's come along, particularly my collaborators, a few of who are here today. And it's really a team effort. That also goes for my colleagues at Abertay, a brilliant team, so I appreciate you all being here today as well. I think that's me. Thank you.